So we're going to start off with Sam Saffron and Jeff Atwood. Jeff Atwood's pretty well known. He runs this coding horror blog. Do people read Jeff's blog at all? Okay. And Sam and Jeff have been part of a team that put together this new Discourse project to revamp the state of online forums. You know, so like, why are we all suffering with PHP BB still? You know, it's 2013. So they're going to talk about some of the work they've done trying to make that run fast. And you know, it's an app that's done in Ruby, and they've learned a lot doing that. So Jeff Atwood, Sam Saffron, are you guys ready? Okay. So big welcome.
Hi, good morning, everyone. This is my first Ruby conference. I know it's a Ruby conference because I saw skateboards. So I know it's Ruby. That's awesome. So my background, if you don't know, Sam and I worked together on Stack Overflow, starting in about, what was that, 2010? 2010, yeah. And that was a .NET project, and it was obviously closed source. After I got out of Stack Overflow and Stack Exchange, I wanted to go in a different direction, and now we're working together, fortunately for me, on the Discourse project. These are both distributed teams. The Discourse team is all here today. They're from France, Canada, and Australia, and I'm, of course, in the East Bay. So both of those teams are kind of distributed. The Stack Overflow team a little bit less so, but it's exciting for me to work on an open source project because I felt like this is sort of the way I summarize Discourse, you know, in a way that's, I think, very clear for the audience. There's really three goals with the Discourse project. One is that we really want people to get off PHP. I'll have more to say about that. But I want a sane tool chain, a good tool chain, a tool chain that you won't feel like bad about yourself in the morning for using for a project. It's also a JavaScript application, meaning it's a ball of JavaScript. I believe this is kind of the future of development on the web for things that are truly apps, is they will be balls of JavaScript. It's not really about the HTML and CSS. It's about you serve a ball of JavaScript, and it's really an app delivery system. And of course, the final obvious mission is go from unhappy forum software to happy forum software, because with Stack Overflow and Stack Exchange, we conquered a lot of the Q&A things that I thought really helped, but there's a lot of communities that don't really fit into this Q&A model, where it's much more social, it's much more about hanging out. And although, you know, Stack Overflow is not really about hanging out, it's about learning and getting things done. And that's not right for everyone. But the thing I really want to leave you with is what I call server herpes, which is why I'm happy to be here, and I'm very happy to be in the Ruby and JavaScript ecosystem, is I want people to ultimately have a killer app in the form of Discourse that's completely free, completely open source, that you know you want to use, and you want to deploy a Ruby toolchain on your server to get it, right? That's ultimately what this is all about. And the part that Sam's going to talk about is what we're doing to improve the Ruby ecosystem, trying to feed in a lot of performance feedback back into the Ruby community, back into Ember, about how we can do things faster so we have a really nice performing application. And with that, I'm going to let Sam take it away.
I think I've got a... this is a bit of a dangerous talk for me because I'm focusing completely on the Ruby side of things. And I wanted to spend a little bit of time telling you stuff that you need to know. And a lot of times people get a lot of tunnel vision and only look at one problem. And the one thing that you all must do is always look at your front-end performance before you freak out about your server side. Because when Steve Sodders was doing a lot of work years and years ago, that's what he discovered, that often, you know, we focus on the server, don't focus on the client. This talk is about Ruby, but if any of these tools are foreign to you, take a pen, write them down, and go and visit. Visit Web Page Test, Google PageSpeed, YSlow, run that on your sites. There are bunches of talks online about them. Definitely do that. Web Page Test is awesome. It gives you screenshots of how your website is rendering, and you can find out that, yeah, the JavaScript's in front, and if I moved it to the back, I'd save half a second here, or I'm not compressing stuff. It's endemic in our community to do stuff that's really bad, even at high scale. These are sites that, you know, top 3,000 sites in the world. They're huge, but they do really, really bad stuff in general. Here you can see in this little picture, you can see a place where Ruby is taking ages on this site. This is a repeat view of chow.com. And you know, it's a sign that there needs to be a bit more caching, a little bit more work on the back end. But then also you can see there's a whole part of not Ruby that's blocking the rendering. So if you go and spend all of your time making that Ruby fast, and you could have just taken a bunch of JavaScript from the top of the file and pasted it at the bottom, and saved yourself 3 weeks of work, I mean, that's kind of silly if you don't do that. Similarly, you can see this is pennyarcade.com. And that's like a pretty typical thing, you know, a nice half second that's just because they didn't take the JavaScript and move it to the bottom. But there's also all sorts of other things, like not compressing stuff. You know, that's just a switch that you put inside your web server. Literally 2 minutes to do that. So definitely, this is all going to be focused on Ruby, but go and look at these tools. Run these tools on your sites. Don't forget about them. And don't just get tunnel vision on the stuff that I'm about to talk on. Make sure that you look at your front-end performance. So the first thing I wanted to talk about is this. What this means to most people is that optimizing is pointless and don't bother about performance. This is something that I hear a lot. It's like, yeah, premature optimization, go away. Of course, if you continued reading what Knuth was writing in the same paper, then you see that there's a bunch of stuff going. He's going, yeah, our intuition is horrible about performance. If we think it's A, it's usually B. Unless we measure, we're not going to be able to tell. And if he had this unicorn world where the tools are constantly feeding back information and telling us, you know, this is slow because of that. And as you're compiling, it's telling you, fix this, fix that, fix that. 2013, nothing, right? We're just playing it blind. We deploy stuff to production. We come back, and 3 weeks later, yeah, this is slow, that is slow. We have no feedback or visibility about what is going on. And that's not built into our workflow. And this talk is about measuring. This is about showing you some tools that you can use in your everyday life to measure stuff and have proper visibility about what your app is doing in Ruby and others. So I wanted to talk about something here that came up on Discourse that was rather interesting. We had this issue that was reported that there's runaway CPU. I don't know, how many people have seen here a runaway CPU? Ruby just goes high up. And have you found an easy way to find it? What do you do? Like often you're just lost, right? So you just maybe go through your commits and revert a bunch of stuff until you find, yeah, it was this commit, and it's kind of voodoo. You don't need voodoo anymore. In Ruby 2.0, you get DTrace probes, which is really, really handy. The unfortunate thing about DTrace probes is that they're under the CDDL license, and that license is very, very aggressive against GPL, so you can't run it on your servers. There's actually STAP on Linux, very hard to install, very hard to configure if you really want to, but you can get that going that gives you the DTrace probes. And this it's embedded into our framework. An unfortunate thing about DTrace is the documentation of what we do is really, really poor. A fortunate thing about it is it's quite self-documenting. So if you run this command, I'll try and put the slides online so you don't have to write every little thing down. You run this command, you can see all of the commands that you have with DTrace. And in this particular example, I'm talking about runaway CPU. So here's a DTrace call sampler. And basically, this is running 5,000 times a second, gathering these instruments of saying, you know, this method was last entered here, and this C method is last entered here, and taking all of that into a pile of, taking all that information and aggregating it. At the end, you get a report. So in this particular thing, we had this CPU that was hovering at 20%, and you kind of open Pandora's box, and you discover that array each is being called, and this ice cube gem is being called, and that gives you a place to look at, right? So now I've got some ideas of what's going on. Times, I can see stuff to do with times, div mod, dividing times, iterating through arrays. Okay, I'm starting to make sense of what's going on here. Another tool that you have that you can run on Linux is rb-trace, which is really awesome. And that allows you just basically to attach to a process and just listen to everything that it's doing. So you can run it in firehose mode. And for high CPU, rb-trace is absolutely awesome. So you get like, it's a huge XML file. I cropped it just so you kind of get a bit of a taste for it. But you can run it yourself on your own app and see it. So I'd recommend running rb-trace and having a look at that. And it showed me the same kind of thing. Ice cube scheduler, recurrence rules. OK, something is going on with the scheduler. And the old school is really good for the old school way of just patching methods and figuring out, putting your very specific instrumentation exactly at the spot you want is really great at getting like that super high fidelity information of what's going on. And this is like really a few lines of code to write. You hack it into your app, get the information out, take it out of your app, nothing's dirty. And it's a very, very simple technique. This is just basically patching a method and gathering time. And I use this all the time, right? It's a technique that I love using. At the end, it showed me, yeah, there's this one schedule that's taking ages. Why is it taking ages? And this is about measuring. So what you do is you measure. So you look at this schedule, and you look how it's structured, and then you chuck it in a benchmark, and you see what's happening. And then when you do the math, you see that every second, we had a 21 millisecond thing running in this schedule. And that's what was causing it. So that was basically the steps from going of some customer reporting the issue till you found out what it was. And then you look at the code and you submit patches and try and be a very good citizen about it. But having this information allows you to actually report this information back correctly. And at this point, I'd like to take a little break and talk about rb-lineprofiler and the tooling that I use in general when I'm when I'm doing this stuff. Just one sec. I'll exit show and go here. OK, this is Discourse. And I just want to give you guys a bit of a picture of the tooling that I use, that I like using. And this is MiniProfiler, this little thing over here. And whenever I reload a page, it shows up over here, and it's showing me how long it took on the server. Is that cropped? It's saying 127 milliseconds took on the server side. It's breaking down the various times. So the action took this long. Rendering took that long. I can show trivial. It suppresses trivial timings, but I can show trivial timings. This is in milliseconds, so it's 1.6 millisecond this started 123 milliseconds after the beginning. Got tooltips for everything. This number is very interesting. Because in general, like a lot of the performance issues that you look at are all going to boil down to SQL if you're running a SQL app. So that's very important to know, and this gives you the breakdown. So if you see it's spending 5% in SQL and 95% in Ruby, you've got a Ruby problem. 95% in SQL, 5% in Ruby, don't bother optimizing Ruby that much. It also shows client-side times, which is really handy. And you can share this with your team. So there's a share link at the bottom that you can use. Which is cropped from the screen. But so I can go and share this with the team and show them that this stuff happened. The client side is very important because it'll tell you when the paint happened as well. So when is the first time that you actually, the user saw stuff? So even though we had the information ready in 153 milliseconds, the first time it was painted was then. And there are a bunch of hidden, and the next thing I do after I look at that is I'll look at the SQL trace. And this works through the various SQL statements that are running. And I can see back traces of where they came. And I can see gaps between the SQL statements. And the gaps actually are very handy because I know that this was called in current user, and this was in has visit record. So I know that there's 4 milliseconds between these two things. So I've actually got good visibility into the actual pipeline of the request. And I'm looking here for queries. I'm looking for a few things. I'm looking for queries that are running that shouldn't run. I'm looking for queries that are taking too long to run. So anything that's taking 40 milliseconds every time is probably something that I'd be very worried about. I'm looking for gaps. I'm looking for too much data being selected. I'm looking for repeated queries, like if I've got an n+1 problem that can just be solved by just, instead of querying a row, query a set. And then there are a bunch of hidden features in rb-lineprofiler that are pretty wonderful. So you do pp is a special, expert mode, I guess, in rb-lineprofiler, and there are a bunch of stuff that you can do. If you're using Ruby head, you've got a memory profiler, which I'll be showing a bit later on in this talk. And what I wanted to show you here is, because a lot of these slides will actually talk about it, is Flame Graphs, which is this thing. And every time I reload a page, it changes a bit. And what this is doing is it's gathering call stacks. So it's sampling call stacks. I can see there are 177 samples. That was a 120 millisecond page, so it's approximately every 2/3 of a millisecond I'm getting a sample. And it's gathering the entire stack trace, and it's laying it side by side. And I can zoom in here and see actually what's going on. And it's all, it's all color-coded. So, for example, this little green line is coming from async exec, which is running SQL. So the green line is running SQL 47% of the time. And then I can see what happens after it runs SQL. OK, it runs SQL, great. And then afterwards, here it did a map exec, so it just moved on to something else. I can see the time it takes it to prepare to run SQL when it's using active record, for example. So here, for example, you can see there's a gsub inside acts like, or I can see that it's building joins before it's running the query. So I can get a good picture of, what is actually running the SQL and what is the overhead around it. And that helps a lot when you're optimizing frameworks, for example, or you're looking at, you've got a way too complicated process and you want to simplify it. And at that, now I think you've got a bit of a picture of what that is. It runs in production, runs in development. Just turn it on and forget about it. Yeah? Yeah, so there's an exclusion list inside MiniProfiler that you can exclude certain requests, because it can get very, very floody if you don't exclude things that are happening a lot that are very, very short. OK. OK, I will do. OK. So that's the demo. And I'll talk about a few little stories. So we had an issue at Discourse. The dev speed was very, very atrocious. We have a lot of JS files, a lot of CSS files. And traditionally what you do is you just kind of give up on debugging. And you just serve it all in one bundle. And OK, so debugging's a little bit crappier, but development's fun. I really hate those kind of solutions that compromise my experience. So I tried to figure out why that's happening. And you can actually figure out that crawling the middleware, that it actually has to walk up a whole big stack for every single request, for every single asset. So it's spending like 5 to 10 milliseconds for every asset just to walk up the stack, go to the router says nothing changed and goes back down the rack middleware stack. And that includes stuff like current user initialization, e-tags, a whole bunch of stuff that you don't really need. At Discourse, we just wrote this little middleware that just sits absolutely in front. And instead of it having to crawl all the way up the stack, we just go there first. And the impact of doing this kind of work, of serving the assets earlier rather than waiting for it to crawl through the whole middleware stack, is pretty staggering. So when you look and see it, it moved 1.6 seconds faster to get that to load. And that's very significant when you're developing. If every time you press refresh, it only takes 1.5 seconds as opposed to 3, it's massive. Next up, I want to talk about memory in Ruby. This is really, really exciting that in Ruby Head now we have a much better way of figuring out what's going on with memory. Why is our app taking up so much memory? What's doing it? Who's responsible? I feel that it's a huge barrier for Ruby to displacing PHP. The ability to deal with less memory. If we had leaner processes, we'd be able to run on more VPSs. We wouldn't need to hog so many resources. So dealing with our memory problem is pretty important for the community. and the tooling's been pretty bad. And the reason is because we just didn't have the hooks in MRI to do that. This is in Ruby head, so you can actually install that in RVM or in RBN if you can get the latest Ruby. And there are new APIs that allow us to figure out where an allocation came from. So it's a lot of the tooling that I'm showing is just very, very trivial to run. So with MiniProfiler, you just cover a block into it and then get a big, big report back. And we love Ruby a lot. We spend 10,000 bytes in our process on the word Ruby. And that's there. It's retained. Meaning retained, the difference between retained and allocated. Allocated is just you allocate it and then the GC eventually collects it. This is stuff that's sitting around in the process forever. And you can use MiniProfiler to figure out all of these things. So it gives you reports on retained objects. It gives you reports on amount of memory as well that it's allocating. And these are things that if we had this information, we can go and address Ruby gems and fix this. And the amount of objects that we're retaining is staggering when you look at it. My pet peeve is probably MIME types, which is one of the most problematic gems that we ship by default in Rails. And the reason is it's parsing a whole bunch of files, and these files are all taken and shoved into arrays and left in memories. And when you look at what it is, what information is it storing there, it's mapping all sorts of obscure MIME types that you'll never, ever, ever, ever use, just for the mail gem, just when it deals with attachments, it'll have the actual mapping that it needs. And interestingly, there's a little map of MIME types living in rack as well that we probably could leverage that is probably good enough for us. Or we could just load this on demand and cache it. There are a whole bunch of addresses, of things that we can do. This addressable gem was actually coming in from a dependency that we decided to pull in that's optional. We don't even use it. So with this information, we can figure out which are the problem gems that we have and just kind of either eliminate them, fix them, report bugs. We have information. We're empowered. And once we do this, you know, we can help our GC, because every object that we allocate is an object that we need to free, or an object that we need to crawl if we don't have to free it. And the GC in MRI is very, very, very dumb. It just walks through a whole bunch of objects every time. It's got a little bit of, it's got a whole bunch of optimizations, but conceptually, you're basically doing a whole bunch of work when the GC happens and stopping the world. And that can take ages. And yeah, you can run the GC out of band. It gets complicated. There are a whole bunch of tricks that you can do. Yeah, sorry? With what? The thing is that Ruby 2.1 is addressing a lot of this with incremental GC. Actually, when I benched it, Ruby 2.1 isn't much faster for us from what I've seen. So it's addressing a whole bunch of stuff. There's a new type of GC that has, it takes strings and it deals with what it calls shady objects. So there are some objects that you can shove into another place that doesn't crawl as much. But the issue is that it's not all objects that get this advantage. And there are a whole slew of optimizations that are needed. And the big serious thing is, like, we've got the frozen string problem now that exists, that you're going to need to use new kind of syntax in Ruby to get the full advantage of it. So I'm happy to talk to you guys about it and kind of show you the various things after the talk, if you'd like. But yeah, the things to remember about allocating stuff is that there's an immediate cost and there's a deferred cost, which is releasing it or just crawling it. And this is us looking at a single request. So we zeroed in on a request and we're like, yeah, what is this request allocating? And like, it's fascinating that the PG gem, the gem that's talking to the database, is allocating this tiny amount of objects, and then Active Record on top of that is allocating a massive amount of objects. And when you look at the memory, it's even more scary. So the actual MiniProfiler will look at memory allocated as opposed to just number of objects. And looking at memory is fantastic because it allows you to actually see the impact in memory. This is fixing an offender in memory, a pattern that I've seen used quite a bit before. You do an inject and then you do a merge. It's really fancy. Everybody loves it. It's very Haskell-y, I guess, but it's very dangerous as well because they have allocated 373,000 bytes there. Fixing it is just moving to a standard pattern where you're just using a hash table and suddenly reduced, you know, 300,000 bytes every request of allocations. And that's faster GC, faster everything. And this is endemic in our framework. Rack E-tags also was copying the whole payload of what's on the page every time you do a request, just to get a hex digest. But you can do a hex digest incrementally without needing to allocate anything. So I submitted this patch that now will do it without copying the string. So if you have, a 100K string, you don't need to copy it another time every time you're calculating the E-tag. And by the way, all of you are doing this. Like, you're all running Rack, and you've all got this problem. How serious, you have to measure how serious it is, right? And it's very hard when it comes to GC stuff. And when I'm looking at, you look at every query. Do I need this query? Can I cache it? Can I join? These are questions that you should be answering. And all sorts of things that you may have thought are really cheap are not cheap. Exceptions are not cheap. This is running on a really, really fast computer. Every exception that you have is 0.3 milliseconds. Not a big deal. If you're running it in a loop, it's messed up, right? Suddenly it's a 30 millisecond thing for nothing, right? Because you shouldn't be using exceptions for non-exceptional cases. So you can use rb-lineprofiler to track this. With TracePoint in Ruby 2.0, you can actually say, tell me when exceptions happen. And then in rb-lineprofiler, it'll show you where the exceptions happened. And, OK, that happened because I'm not using the right gem. So I changed it to the high Redis gem, which is the high performance Redis gem, and all of these exceptions go away. Require is also not something that is trivial in Ruby. So it's actually more expensive than an exception even. So you have to be very careful if you've got a loop somewhere that is calling something that is requiring something. Don't require in a loop, definitely. Or don't require stuff when you don't need to require it. And measure. Measure, measure, measure. If you measure, then you can do it. And if you see the syntax there, that's what you can inject in rb-lineprofiler. You can say, just instrument this for me, instrument that for me. Put a counter here for me, put a counter there for me. And that'll help you get this visibility. The flame graphs are what I showed you earlier. And they're incredibly accurate now. Back in the old days, we had very inaccurate flame graphs. And you can see the difference in the picture. It's like the stack traces are just so much tighter now. And they're happening so much more consistently. So you've got very, very high fidelity view into your process. And we can look at that and actually correlate it to pull requests into Rails that fix Rails. Because we saw it in the flame graph. And then we went and fixed Rails, and this is actually correlating the two. And finally, the thing that we need to do to figure out what's going on is run benchmarks. And Apache Bench is the perfect thing for figuring out really, what is the last line of defense is just looking at what the app is really doing. We can do all these micro-optimizations, but the app itself is not getting faster. So this is an example of a series of optimizations that I did that moved, our app performance forward. And it's a whole bunch of small things. In Discourse, we have a benchmark that we can use to benchmark Discourse and do a whole bunch of very realistic things with the app. And you can use that to we can use that as a community to benchmark Rails, because we run on Rails 3 and Rails 4, and we'll want to run on Rails Master. So we can use this as a benchmark for the community. And we can have numbers. And we can take these numbers, and we can graph them over time, like PyPy do. And imagine how wonderful that would be if a regression happened in Rails and we picked up on it the day it happened, as opposed to releasing a version of Rails and going, yeah, it's slower. But we could have had this, right? We have all the information. We just need the hardware, and we'll be good to go. And also, we'd be able to highlight the great contributor and say, look, this guy has been helping Rails a lot or helping Ruby a lot, and this is how much better it's gotten. A lot of what we think about performance is that, people tell us that it's better. But if we have a picture that's showing us how better it is, that is a much better state to be in. We'll be much, much happier Rubyists. So back to, I guess, what you can do as developers. You can start integrating this into your workflow. You can start using rb-lineprofiler. You can start running flame graphs. You can look at memory on your app. Instead of taking like this reactive approach towards performance, a much better approach is to have that integrated into your life. And something that, it's not that hard to run. You just include a gem, pretty much, and configure it. And all of these tools are pretty wonderful. The ability to be able to tell which gems are hogging the memory in your app and do an audit like that. And you know, sometimes it's as easy as just putting require false and just, you know, that 1% users that need that are consuming your app can require it, right? And then you're not loading all of these things up. It's fascinating when you look at actual load. You can look at because we can run flame graphs on anything, we can actually look at, sorry, PowerPoint, go away. Okay, I'm running out of time. But you can actually look at you can look at the load time of Rails, and we can see a visual picture of where the load time of Rails is taking us, and you know what areas we can work on to make it faster. So I guess hopefully I've convinced you all to start measuring your app, start using the new tooling, and hope you enjoyed it. Thank you.